Ah. Oh gosh. Okay. There we go. Hello. Hi. Hello everyone. I hope that we're doing well. Hey Astral, how you doing? You doing all right? I hope that you're doing all right. Oh man. I am doing just fine. I had exactly the same dinner that I had last time, so we hope. Yeah, the Z Jimmy jump scare. I need to my lovely lecture hall. I'm not even in here. Oh, there I am. Sorry, Z is not here today. Z isn't here today, so Z has to go back to the Shadow Realm. Z is out doing more important things, probably. I have great faith in her. hmm Oh man, I can't believe it's already March. Like time's going real fast. Doing good, but been doing PLA hunts with little success, but it's fun. Oh, that's good. That's good. I want to do that. I need to get a new controller that won't be so hard on my wrist. I've been doing a lot of drawing lately, and my wrist is not happy with me. Oh man. I wish I don't know. I want to just like get a bionic arm or something, but I don't think technology's good enough to get the fine what is it? The fine control I need. Hey Bushi! Hello, can't stay for too long because even though there's no practice, I have to front load work before I head out of state for the tournament this coming. Haha, been there, been there. But thanks for dropping in. Got a shiny Galarian Moltres, but already have I haven't even seen a single one of the shiny birds. It's ridiculous. I have not. Oh yeah, prosthetics in general are super cool. I'm like super interested in prosthetics. I guess I haven't looked at them lately, but I would love to make prosthetics and learn more about them. Oh, fine motor control is the phrase. Yeah, that's my one thing is like I don't think prosthetics are at the point where I could get enough fine motor control in the hand to do proper art. Like technically it's supposed to be you're supposed to draw from the wrist, and if it was just that would be fine, but I have bad habits, I think, when it comes to how I move my hand when I'm drawing art, which is part of the reason that my wrist is all screwed up, and also part of the reason why I probably couldn't use like a prosthetic arm to draw very well, because I'm not drawing with my arm, I'm drawing with my fingers more often than not. Oh well. Oh well. Well, either way, I follow the Jingle Jam, and one of the charities does bionic arms, and they get more and more advanced. I know the advancement is crazy. It's really incredible, some of the things that they can do. Like, I really need to catch up on it, but every time I check back in on prosthetic technology, it's like, oh my gosh, they can do that now? With that said, I just want to say thank you so much for your support. I hope your stream goes great and fun. I can't do much from my end other than win that tournament and scream for V-Theorem. Thank you. How cool would it be if you won that tournament and screamed for V-Theorem? Nobody would know what you were talking about, but somewhere far away from wherever you are, it would resonate in my heart, and I would feel a rush of power that I've never felt before. But I hope that you do well in the tournament and safe travels as well. That is so cool. That is so cool that you do that. I used to do archery. If we go together, if we went together, we could accomplish a great deal. He won last year's tournament too, so I got to uphold the title. Awesome. I mean, the probability that somebody does isn't zero. That's true. Somebody could know what V-Theorem is in that audience. This is true. It's not a very few things in this universe in general have zero probability of happening. And that's kind of one of the principles that statistics works on, right? Very few things have a probability of true zero, and that's why we can never prove anything with statistics. We can only provide increasing evidence, right? The people who do Ido and people who watch anime and VTubers is a Venn diagram. You know what? That's not surprising to me. Yeah, I don't know why that did not occur to me. Like if you reckon I technically can just spontaneously reform. That's true. You never know. You never know. Never you never know what could happen in this life, right? There are many things that we are not aware of, and many highly improbable events that still occur all the time. I can't think of anything that's happened to me recently that's been highly improbable that happened, but the world is a strange place, and cool things happen. I don't know. Oh, I should probably get into the lecture, shouldn't I? So, today we're following up on Factorial ANOVA. Last time we talked about Factorial ANOVA, and we spent a lot of time on interactions. So, two independent variables working together to do something different than the sum of their parts. Today we're going to talk a bit more about how that is calculated and also how you would follow up a Factorial ANOVA. Oh, right. Did I mention that this is the last lecture that I have in this series? I guess I have like one or two others that I probably could tack on at the end, but I don't think they're like developed enough to go in here. So yeah, for now we're reaching the end of my repertoire of stats lectures and the other ones that I haven't done I might not do. So this is the last one that I have planned, which means that in the future I'm gonna be able to go back to my shenanigans. It did go quick, didn't it? It feels like it didn't go quick because I did have to take that big long break in the middle there, but it also did kind of go quick, didn't it? Yeah, it's weird. I guess I have another like I could do a series on research methods next or social psychology. But I might just do like random sporadic lectures on random topics here and there and just a bit more fun. You joined after the break, so yeah. There was a long like 2 or 3 month break in there somewhere. Definition of time flies when you're having fun. Yeah. Who would have thought giving stats lectures could be fun? Well, it's thanks to all of you. All right, but yeah, I think I do have plans for the future. Don't get me wrong. I'm not done. I have a whole list of I have a whole list of things that I want to do next. So like, what is it? Where's my list? I've got I want to do a video on Psychopath's crime coefficient and like measures of validity for psychological measures and whether it's a valid measure or even a reliable measure. I want to do some ranking stuff for like tier list of APA's style's weirdest rules and tier list of questionable research practices. Just some for fun stuff. And then Fi suggested doing a stream on the concept of statistical outliers, so I might end up doing that as well. But this is the last in this particular series. Oh, it feels weird. Tier lists, yeah! I know. Oddly enough, tier lists actually they're kind of a pain to set up. Mainly just getting all the images ready is a pain. I kind of like want to do a text tier list because that would be a lot quicker. But yeah, I have multiple tier lists on the brain. There's also a tier list that I wanted to do with Phi, but I don't remember what it was. I don't know if he remembers what it was either. I'll have to check in with him. Anyway, let's get going. So let's start off with a little bit of review. Can anyone tell me when we would use a factorial ANOVA as opposed to any other type of ANOVA? Anyone remember? What makes a factorial ANOVA different? The hint is in the name factor. Factorial. When we want to test how two or more things affect something together, yes! And it doesn't even need to be affect something. Like, I think the main appeal of factorial ANOVAs is that they can test for interactions, but you don't have to like predict an interaction to do a factorial ANOVA. I actually, my friend defended their dissertation today, and they succeeded. So congratulations to them. We have another doctor in the friend circle, but they actually, one of their main hypotheses for their dissertation was it wasn't a factorial ANOVA. It was a multiple regression, which is similar. But they actually didn't predict an interaction. Well, one of their predictions was an interaction, but another version did predict an interaction. So just generally, yes, when we want to test for interactions, factorial ANOVA, but also just generally when we have more than one independent variable. Usually that means you're predicting an interaction, but it doesn't always mean that you're predicting an interaction. All right. What goes in the denominator of every F test? So ANOVAs are F tests. They produce an F value, which is a ratio. It's a ratio of something to something. So what goes on the bottom of the F ratio? What is the denominator of the F ratio, like conceptually? I'm not looking for the name of the thing, just like, what does it represent? What does the number on the bottom of the F ratio represent? Yeah. Yeah, the expected error, our estimate of sampling error, exactly. Or like the variance within conditions that we cannot explain. Yes, exactly, exactly. Great job. And finally, can anyone tell me what an interaction is in their own words? What is an interaction? What does it mean when I say interaction or these two variables interacted? What does that mean? Or you can give me an example of an interaction. I'll take that too. Interaction. Mr. Kitty, do you know what an interaction is? Does Mr. Kitty know what an interaction is? Mr. Kitty's busy. The change in the outcome from two variables changes together doesn't act as the sum of the two changes independently. Yes! Yes, 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 yes. That is a great way of putting it. Yes. The effect on the dependent variable, when two variables are together, their effect on the dependent variable is different than if I just added together their independent effects. Yeah. So that can mean one of them amplifies the other's effect. One of them it could also mean one of them cancels out the other's effect. It could be that they reverse the other's effect. Like there's a bunch of different ways an interaction could happen, but when you put the independent variables together, something different happens than you would have expected just adding together their separate effects. Good job, good job. All right, so there's our review. Today, we're going to talk about the source table. So like, you know how we did tables for ANOVAs? We're going to talk about that with this example here. We're going to talk about how the bits are calculated, and we're going to talk about effect size for these factorial ANOVAs. And yeah, we're sticking to a two-way factorial ANOVA. So we're sticking to, there's only two independent variables, but there can be more than that. My friend who defended their dissertation today, their test actually had 4 independent variables. I've done one of those too. I do not recommend it, by the way, but you can have as many independent variables as you want. It's just every independent variable you add, it gets worse. Yeah, my dissertation also had 4 independent variables. I don't know how we both let this happen to us, but it's not recommended. I do not recommend it. Especially when you get to the graphing part, trying to graph a 4-way interaction if it pops out significant, which mine did. I don't think theirs was significant, but my 4-way interaction was significant, and trying to graph it was a bit of a nightmare. 3D GIF. Yeah, the thing is, even 3D wouldn't be enough for this. It would need to be 4D, right? Because there's 4 variables all having an effect on the dependent variable. So I'd either need 2 3D graphs or somehow a 4-dimensional graph. Horrible, isn't it? That's why it's a GIF. Use time. One of the variables actually was something related to time. And I actually know how to do that. In R, I know how to create a graph that's animated that shows change from one state to another. I could I couldn't make it a 3D GIF, but oh my gosh. I might have to try that. I might have to try that. That would cut the graphing down to only 2 graphs instead of 4 for the 4-way interaction. Oh, all right, let's get rolling. Okay, so this is a hypothetical source table of a hypothetical 2-way factorial ANOVA. In this case, it's 2-way, so we have 2 independent variables. One is the audio, and I'm going with anime stuff, right? Because, you know, we've got 2 conditions in the audio. You're either listening to the original Japanese with subtitles, or you're listening to maybe the English dub or whatever language you're listening to. You're listening to it in the dub. Then the setting of the anime either takes place in the US, Brazil, or Japan. And our dependent variable is how much people like the anime, I'm guessing, or like how much people enjoy their viewing experience. It's my personal experience. I'm not a sub or a dub person. I tend to watch the sub more often, but there are definitely some anime that I enjoy better in the dub. And I found that usually I like the dub better when, like, the English dub better when the anime is actually set in the US, which is why I thought that this might be an interesting thing to do. Like, maybe people tend to like the dub that matches the location of the show. If I rewatch a show, I usually swap to dub. I actually do the same thing. Astrologos, I do the same thing. Like, if I decide to rewatch a show and it has a dub, I'll watch it dubbed the second time. I'll watch the sub first and then the dub. Oh yeah, Mori Bakano. That is exactly the show I was thinking of. The Bakano dub. I think the Bakano dub is far and away, like, I'm not saying the Japanese voices for Bakano were bad. They certainly weren't. But the English dub for Bakano is impeccable. I think the only characters that I like better in Japanese in Bakano are Isaac and Miria. The English dub didn't quite get the same energy as the Japanese dub for those two, but like, they were still really good in English. The Bakano dub is top freaking tier. But anyway, yeah, essentially, I'm kind of testing here if there's a general preference for sub or dub, if there's a general preference for a certain setting for an anime, and then whether the dub or the audio you're listening to interact with the setting of the anime to predict how much you like it. So you'll notice something interesting about this source table. We have sum of squares, and we've always had, sum of squares between, that's your sum of squares between your conditions. We've always had sum of squares within, that's the sum of squares within the conditions, and then sum of squares total. So we've had those for all of the ones, and we've also always had the degrees of freedom between, within, and total. And we've had our variance between and our variance within, and then our F value. That was our variance between and variance within, typically. But now we have more than just that. We also have to be able to calculate the variance for factor A on its own, in this case, audio. So this is the variance just due to whether you were listening to sub or dub. Then we have the variance for factor B. This is the variance just due to where the show was set. And then we have the interaction. So that means we have the sum of squares, degrees of freedom, and variance we have a bunch of them. We have it for overall between conditions. We have it for our first independent variable, our second independent variable, their interaction, and finally sampling error. And this means we actually also have 4 F values. We have 4 significance tests here. We have the sort of overall F value for the overall ANOVA. Then we have factor A's F value. This number determines whether there's a significant main effect of your first independent variable. In this case, if I reject the null with this F value of 24, that indicates to me that there is a significant difference in enjoyment between listening to the sub versus the dub, or watching the sub versus the dub. Then we have an F value for factor B, in other words, setting. If we reject the null on this, that indicates to me that there is a significant difference in which setting people liked most for their anime. And finally, we have an F value for the interaction. If this one's significant, that indicates that the effects of setting and, when you combine the effects of setting and audio, there's something interesting going on in there. Setting matters more for some types of audio than others, kind of thinking about it that way. That's one way to put it. So we're doing 4 significance tests. 1 for the overall ANOVA, 1 for each independent variable, and then a final one for the interaction between those 2 independent variables. Before, we were only doing 1 because we only had 1 independent variable, but now we have to do 4. 1 for each independent variable, 1 for the interaction, and then just kind of 1 for the overall ANOVA. This top F value, I wouldn't consider it very useful. Mostly, if you're doing a factorial ANOVA, you'd only pay attention to these 3. So, as before, the sum of squares between plus the sum of squares within equals the sum of squares total. That's still the same. Degrees of freedom between plus degrees of freedom within still equals degrees of freedom total. That is still the same. This has been true on all of the types of ANOVA that we've talked about. You can still get, For the repeated measures ANOVA, we broke up the variance within and the sum of squares within into 2 pieces. we broke it up into between subjects, which was variance due to individual differences, and then whatever was left over was error. This time, we're breaking up the between treatments sum of squares into pieces. We're breaking it up into 3 pieces: sum of squares due to factor A, sum of squares for factor B, and sum of squares due to the interaction. So these 3 things, the sum of squares for A, B, and the interaction, are actually just pieces of this sum of squares between treatments. So they all add up to 260 because they're just different pieces of that 260. The same is actually going to be true for the degrees of freedom. The degrees of freedom for A, B, and the interaction add up to your degrees of freedom between. They are just little pieces of the degrees of freedom between, split up between your independent variables and the interaction. So, repeated measures ANOVA broke up the within treatments variance. This ANOVA breaks up the between treatments variance. We still calculate the variance the same way. It is your sum of squares divided by degrees of freedom equals your variance, and that's the formula, more or less, that we've been using all semester. It feels weird to call it semester. All throughout this series of lectures, your variance has always been the sum of squares divided by the degrees of freedom ever since we started working with sample data. So this has not changed. This is still the same. And it's the same, by the way, for the sum of squares within, if that wasn't obvious. I guess I just didn't add that to these animations. Oops. F values are pretty similar. So for the one-way between treatments ANOVA, we got our F value as the variance between treatments divided by the variance within treatments. And that's still true for this top F value. But we have 3 other F values to worry about now. We've also got the F value for our first independent variable, in this case, the audio, sub or dub. That is calculated by taking the variance between treatments for that specific independent variable divided by the variance within, because that's our only estimate of sampling error we've got. So this was going to be on the bottom of all of them because it's our only estimate of sampling error, and that gives us our F value. So it's the variance due to the thing that you're interested in divided by your estimate of sampling error. That gives you the F value. It's still variance due to treatment plus some error divided by error equals F. It's just the variance due to the treatment is going to depend on which treatment we're looking at. Are we looking at the audio people are listening to? Are we looking at the setting of the show? Or are we looking at the interaction between the two? But at the end of the day, it's just the variance for that thing divided by variance within equals the F value for that. How are we feeling? We doing okay? Are you hanging in there all right? Okay? All right. I hope it's okay. All right. So, we have our table here. Let me break this down into the information that you would actually need to calculate this stuff. So we've already talked about how you calculate the between row, the within row, and the total row. Like all of those calculations, all of those formulas are exactly the same as they would be for the between treatments ANOVA, the very first ANOVA that we talked about. That math has not changed for, here, let me highlight them. Let me highlight. The math for this, oh gosh, I can draw a straight line, I swear. I'm going to pull up my tablet so that I can actually draw a straight line. Here we go. Okay, I can do it. I can draw a straight line. No! This is the most difficult challenge I've ever given myself. Okay, so the math for this row, and the math for this row are all exactly the same as they have been for all the ANOVAs we've learned so far. This is not new. Like they're all the same formulas. We don't need to do anything. I just picked a PLA lost satchel of somebody named I Suck Toes. Weird. I like how you can always tell. It's like, is this a satchel that was just randomly generated by the game, or is this a real person's satchel just by the name? Like 99% of the time, it's very, very obvious if this is just somebody the game made up or if it's a real player, and it's usually because they either have like a horrible, like weirdly typed like all caps or no caps at all, or like a really weird name like that, or just like an edgy, chuny name or something like that. And then you can tell if it's generated by the game, where it's like they just took a list of names from like the most popular names in the world or something and then just randomly selected one. Oh, it randomly generates them sometimes. I hadn't realized it. Yeah, yeah. So like if you don't have, I'm sorry, this is completely off topic. But yeah, if you, let's say you don't have like a subscription to Nintendo Online or something. So I'm actually playing PLA through again on a different account that doesn't have access to the online system. It'll still generate satchels for you to find, but they're not from any players. They're just satchels randomly generated by the game. And I think you still get some of those even if you are connected to online. You just get more satchels from other actual players in addition to the ones that the game automatically generates. I think. Like, I know for a fact the game will generate satchels for you to retrieve if you are not connected to the internet, so that you can still take advantage of that mechanic, even if you don't want to pay for online access. I'm not I think that continues to be true, even if you do have the online connection. But yeah, I assumed it was a system exclusive to online because I haven't played not having it. Yeah, no, it's not exclusive to online. It's not exclusive to online. It shows up no matter if you're online or not. It's just like, are these satchels from real other players or are they just random? Yeah, it is neat, isn't it? What sucks though is like if you're not online, of course, and you die, you can't, well, not die, and you white out or whatever they call it. You can't get your items back because nobody's going to pick up your satchel. They don't have an automated system for that. They have an automated system to create fake satchels for you to find, but they do not have an automated system for fake players to find your items, which is deeply unfortunate, but oh well. Okay, anyway. Right. Oh man, you're making me want to play some PLA really bad right now, and I'm sitting here staring at my wrist brace like oh man. I need to try and get one of those other controllers for my thing, so that maybe I don't need to worry about this as much. Because ZA is gonna come out and I want to play Legends ZA. Anyway, so yes, the variance, the calculation for the between treatments, within treatments, and total rules have not changed. They're still the same, but now we have these three new rows. We have variance due to factor A, variance due to factor B, and variance due to the interaction. So variance due to your first independent variable, your second independent variable, and their interaction. And now we have to worry about that. So how do we calculate this? Well, to get the information we need, we are going to need to look at our individual cells and our rows and our columns. And this is kind of the breakdown of the information that you need. I know, it's gross. Here, let me move myself out of the way. There we go. You are going to need the mean for each row. So for example, the mean enjoyment for people who watch the sub was 6, and for the people who watch the dub is 2. The mean for each column, mean enjoyment for US setting was 2, for Brazil was 4, for Japan is 6. You're going to need the total for each row. So this is the total of all the scores in each row, and the total for all the scores in each column. You're going to need the grand total of all of the scores. So if I added up every single score, every single likability rating in my entire study, you're going to need the total number of people in your study. You're going to need the number where if you squared every score first and then added them all together, that's the sum of x squared. And then for every possible combination of your independent variable, you need the mean of that cell. So this is the mean enjoyment for subbed shows set in the US. This is the mean enjoyment for subbed shows set in Brazil, and so on. You're going to need the total in that condition or that cell. So this is the total of all the enjoyment scores or likability scores for people who watched the sub anime set in the US, the sum of squares for each cell, and the number of people in each cell. And you need that for every single one. So this is a lot of information, but this is the information that you need to calculate the variance for factor A, factor B, and the interaction. It's a lot, isn't it? And there's a bit more than that. The main other thing that you need is the number of conditions in each, or the number of levels would be the correct term, the number of levels in each factor. So the number of conditions in each variable would be the other way to put that. So let's go over here. I'm going to move out of the way again. All right. So the sum of squares total, we already talked about how to do this. These are where these numbers are coming from. That's where that 380 came from. I'm just going to kind of skim through this bit because we've already talked about this. We have already talked about this when we talked about calculating it for the between treatments ANOVA. For the sum of squares within, once again, this is the same as before. Just before it was the sum of squares of each condition all added together, but now rather than thinking of it as each condition, we're kind of treating each cell, each combination of our two independent variables as if they're conditions. So we're going to add together the sum of squares of all the cells. So add together these numbers. That's where your sum of squares within comes from. Now, this is new information. This is where we get to the sum of squares for your first independent variable. So we're doing sum of squares for factor A, sum of squares for the audio you're listening to, whether you're listening to the sub or the dub. The formula for the sum of squares for factor A is the sum of the total for a row squared divided by the sample size of people in that row minus the total of all the scores squared divided by the total sample size. So in this case, we have two rows. We have the row for the sub condition and the row for the dub condition. The total for the sub condition is 90. We take that 90, we square it, and then divide it by the total number of people it's in the sub condition. So there's 15 total people in the sub condition. Ignoring which country the show's set in, 15 total people who watch the sub, and then 15 total people who watch the dub. So you're going to plug in those numbers. That 120, of course, comes from this grand total that we used before, and that 30 is the total number of participants in our entire study. That is how you calculate the sum of squares for factor A, for your first independent variable. The sum of squares for factor B, it looks like I don't have a slide for that. The sum of squares for factor B is actually exactly the same, except instead of doing the total for each row, you do the total for each column. But otherwise, it is identical. So rather than 90 and 30, it would be 20, 40, and 60. And the sample size in each column is only 10 people instead of 15, because there's 10 people who saw a US show, 10 people who saw a Brazilian show, 10 people who saw the Japanese show. But otherwise, it's identical. All right. Well, I mean, you should be able to flip the table without it. Yeah, exactly. There's no reason that sub and dub had to be rows and country had to be columns. I could have flipped them. And yeah, there's no reason one of them had to be rows and the other should be columns. I could have easily put it in the other order, and that's why the calculations are so similar, just as you observed that I could flip the table without issue. There's no reason for it to be in that order, and the calculations are very similar for just that reason. It's treating both of them the same way. It's treating both independent variables the same way. Because effectively, you know, like, we don't want to treat them differently. We want to see their individual effects on equal footing. All right, then the sum of squares interaction. The sum of squares interaction is whatever is left of the between treatments variance, or the between treatment sum of squares after you've gotten rid of the sum of squares for your two independent variables. So the sum of squares between, that's your total sum of squares due to the effects of your independent variables plus some error. Once you've gotten rid of the variance due to your first independent variable on its own and due to your second independent variable on its own, whatever is left over is theoretically the variance due to the interaction, probably plus some error in there as well. So that's why, like, if there isn't an interaction, but there's main effects, that just indicates both variables do something on their own, and then there's nothing extra gained by looking at them together. It's just the effects of them on their own. But if there's something in your variance that is above and beyond what the independent variables explain on their own, that's your interaction. So it's just whatever's left over of your sum of squares between after you factor out your sum of squares A and your sum of squares B. Pretty easy to calculate, luckily. So, degrees of freedom. The degrees of freedom between is still the same. It is k minus 1, k being the number of groups. But it's a bit different than before. Now, before we only had one independent variable, so K might be 2 groups for sub versus dub, or K might be 3 groups for US, Brazil, or Japan. But now we essentially have 6 different combinations of our groups. We have US sub, we have Brazil sub, we have Japan sub, we have US dub, we have Brazil dub, and we have Japan dub. We have 6 individual conditions. We have 6 cells. So when we think about K in this context, K is 6 because we have 6 combinations of our independent variables, essentially 6 different situations our participants might be in. So it's still the same formula, but you're thinking about the number of groups a little differently. We have 6 combinations, so we have 6 groups minus 1. Our degrees of freedom between is 5. The degrees of freedom for factor A is the number of groups in factor A minus 1. So factor A was subs versus dubs. We had 2 groups in factor A. So can anyone tell me the degrees of freedom for factor A? It's the number of groups minus 1, and we've got 2 groups. One, correct. 2 groups minus 1. The degrees of freedom for factor A is 1. We had 3 groups for factor B. Factor B was US, Brazil, and Japan. So what's the degrees of freedom for factor B? 2, correct. We had 3 groups for factor B minus 1. Degrees of freedom is 2. The degrees of freedom for the interaction, there's a couple ways to calculate this. So one that we've already kind of covered is we know that the degrees of freedom between is equal to the sum of these 3 degrees of freedom. So if I know degrees of freedom for A and B, I can just subtract those from degrees of freedom between. Whatever's left over is my degrees of freedom interaction. Alternately, you can multiply the degrees of freedom for factor A times the degrees of freedom for factor B. If I multiply the degrees of freedom for factor A times the degrees of freedom for factor B, that will also get me my degrees of freedom interaction. Both of those things should get you the same number. So either way, in this case, we would be getting 2. Whether it's 5 minus 1 minus 2 is 2, or 1 times 2 is 2. Either way, getting the same answer. Degrees of freedom within is the same as it's always been. It's the total number of observations you have minus the number of groups. Just keeping in mind the total number of groups we have is 6. We have 6 combinations of our 2 independent variables. We had a total of 30 people. We had 6 groups of 5 people. So a total of 30 people minus 6 groups. Our degrees of freedom within is 24. And finally, degrees of freedom total is the same as it's always been. You can either calculate it as degrees of freedom between plus degrees of freedom within, so 24 plus 5, or we can calculate it as our total sample size of 30 people minus 1. Either way, we're getting 29. Da, 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 da. After that, to get your variance between, or to get your variance, you just do what we did before. I'll go back to that slide just in case. To get your variance, you just divide each sum of squares by its corresponding degrees of freedom. That will get you the variance. And then to get the F value, you divide the variance for that row by the variance within. That gives you the F value for that row. And there's 4 F values, 1 for the overall ANOVA, 1 for each independent variable, and 1 for their interaction. That's how you calculate a factorial ANOVA by hand. This is assuming that it's entirely between subjects, by the way. You can also have a within subjects variable in there. I haven't talked about that, but you theoretically could, like, say, I have people watch both the sub and the dub of, and then the only thing that changes is the setting of the show. Like, I theoretically could mix between and within, but as far as, like, these slides, they're only talking about if it's a fully between subjects design. Effect size. We talked about eta squared. The generic sort of formula for eta squared here is the sum of squares of the effect you're looking at divided by the sum of squares of that effect plus the sum of squares of your error term. You have 4 sums of squares here. There's the sum of squares for your between treatments variance. So the sum of squares sort of for your overall, or sorry, not sum of squares. Well, you do have a sum of squares for that, but your eta squared for that. You have an eta squared that represents the effect of your first independent variable, an eta squared that represents the effect of your second independent variable, and the eta squared for your interaction. The eta squared for the between f, pretty simple. It's sum of squares between, so 260 divided by 260 plus 120. For sum of squares for your eta squared for factor A, your effect size for factor A, it's the sum of squares A divided by the sum of squares. Whoa. Come on. It's the sum of squares A divided by sum of squares A plus sum of squares within. Same for sum of squares, or same for eta squared for factor B, and then for the interaction, it's pretty much similar. Keeping in mind that eta squared is a biased effect size. It is overestimating the true effect size. So just to remind you what eta squared is trying to do, it's trying to give you an estimate of the proportion of variability in your dependent variable. In this case, the proportion of differences in how much people liked the show due to your independent variable. So how much of the differences in how much people liked the show can be explained due to which audio they had or where the show took place. You'll notice though, theoretically, you can only explain up to 100% of the variance. So theoretically, these three eta squareds shouldn't add up to anything more than 1. What do they add up to? If I add these three eta squareds, 0.5, 0.4, and 0.33, what do we get? 1.23. Hi, Hardy. Happy to have you. Yeah, they add up to 1.23. So theoretically, they shouldn't go to more than 1 because you can't explain more than 100% of the variance. But like I've been saying, eta squared overestimates. It gives you a number that's too big, so it's not a great effect size. It's the easiest to calculate one for ANOVA, but it's not necessarily really great. These numbers are probably overestimates. Well, they're definitely overestimates of the true effects of these things. So interpret eta squared with caution. That's the end of that. I don't know what to say now. That was a quick one, wasn't it? Yeah, it was a pretty quick one. It's only been, what? It's only been about 45 minutes. Oops. I don't know what to do now. Anything you'd like me to clarify, any curiosities, anything like that? Not enough distractions. It's true. Clearly y'all weren't making me go off on tangents often enough. I blame all. No, I'm kidding. There were not nearly enough distractions, but you know what? I think that's okay. I think that's okay today. That's probably all right. I am an eepy. I'm an eepy child. I'm an eepy moth. I could use some eeps and some beeps and some sneeps. Is a straight line a square in time? Not unless it rotates, I would argue. Unless we're talking about a solid square, in which case, so if we imagine a straight line moving along a temporal axis, and then we're seeing where it's been and where it's going, and we see like basically all the after images, there would be a very brief point in time between the creation of the line and like the end of its existence when that line graphed on a temporal graph would form a square. Now this is assuming that the line starts existing the second it's fully drawn. It springs into existence fully formed. But if you're drawing the line, there would be a theoretically infinite number of squares if that line is being drawn along a temporal axis until it hits its full length, at which point it creates the final square and then it becomes a rectangle. Right? I have no idea if that made any sense, but it makes a lot of sense in my head. It makes so much sense in my head, but I have no idea if that made any sense to anyone whatsoever. Interesting so far. The only other response I got to that question was what? It is an interesting question. At first I was thinking of like a square that's like, like so like when you first asked it, I was thinking of a square that was like this, and I'm like, well, obviously the answer is no, because you would need the line to rotate and then go back, like you'd need it to rotate to form the top and then go back in time to form the bottom and then come back again. And then there's a big gap in time in here, and that doesn't make sense. But if you think about it, let's say we have a timeline here. This is time 0 and this is time 100 or whatever. And I draw a line, and the line moves forward in time, so it keeps moving forward in time. Theoretically, at a certain point, that mass of lines over time will form a square, right? That's what I'm thinking. And then the other thing, the thing that I talked about, like going theoretically into infinite, when I'm drawing the line, it doesn't immediately spring into form fully formed. So like the line is this long for a while, and eventually you get something that looks kind of like, you get something that looks like, I'm not drawing this well. Maybe I should draw it from the bottom and that would make more sense. So like you start drawing the line and it's this big, and like that, because it's moving, it's taking you time to draw the line, it draws a square. And then as the line gets bigger, okay, good, good. I'm glad it makes sense. And then it just evens out because the line is done and it just... Did I do good? Did I do good? I like to think I did good. I'm going to give myself... I can't see. I'm gonna give myself a little crown for doing good. This is my prize for doing real good. Yay, I'm so special. I'm a very special moth. Oh no. Oh no. Any other burning questions I could attempt to answer? Ah. I mean, assuming it springs into line fully formed, at any point in time you can scale the t-axis arbitrarily as it uses different units, so arguably it can always be a square at all times except at t0 and t infinite. You're right! You're so right! Oh my gosh. That didn't occur to me, but yeah, the scaling of the axis is what matters here most of all. So theoretically, it's always a line, but it's always a square, but also, well, almost always a square besides 0 and infinity, but it's also never a square because depending on the axis you use, it's like Schrodinger's x-axis. Oh, that's beautiful. I love it. This is a very interesting question. Did that question come from somewhere, or was it just like... Did you just come up with that question? I'm so curious. I can't actually see where I'm drawing, so like where I'm drawing, I can't actually see where it is relative to my model, so I'm trying very hard to put a cat on my shoulder, and it's not working out very well. I thought of it like a year ago. Whenever I ask my math friends, they just go, "What?" Well, they don't have enough of a sense of whimsy in their hearts, is what I'm getting. They don't have enough whimsy in their hearts to truly understand and overthink this appropriately. Oh, that's fun. I like that. It's like when you ask people, is water wet? Oh. Oh no, I erased everything. Now I have to start over again. Maybe I can be a bunny? I don't know. I'm just like stalling for time at this point. I don't really know what else to say. I can have a little halo. Oh, can I have wings? I can have wings. I'd argue water is instantaneously wet when water's added. I would argue that water isn't wet. Water is the wetness itself, right? Because if the definition of wet is like has water on it, water can't have water on it. The water is the water. Angel hair? Yeah, I don't know what I'm doing. Don't look at me. I have no idea what I'm doing. I'm having fun, though. Can't deny that I'm having fun. This is Purikura to me. Oh. What should I be today? I can be anything I want to be. I can be... You know what I can be? I'm so ready. Okay. Also, are we ever going to see the sub versus dub study published in a journal? Maybe one day I'll do that. That would be fun. Okay. Isha. Well, there should be a brief moment before HO2 can align. For that moment is water on water before becoming just one big water again. But yeah, but the question is, can water be wet? It's not about can water be wet before it becomes water. It's already water. That's inherent in the question, right? I feel like there might be some linguistic importance in there, especially if you could move it beyond just anime. Yeah, I do think that that would be, I do think that that's a really interesting question that we could ask about, like, about expectations or stuff and familiarity and liking, and I think that would be a really cool study. Maybe I should do that sometimes. People have been talking about it in the mainstream media since Parasite won awards and Americans were too lazy to watch subtitles. Yeah, that could be a fun study. You know, I've always wanted to like design a study with chat, and I've been thinking it would be fun. But if you define wet as having water in it, you could find a temperature and pressure combination that would make the water wetter. Yeah. As opposed to cheat, it is ice is water, and ice can have liquid water on it. That's true. That's true. Anyway, I have prepared myself for bed. I'm in bed. It was nice knowing you all. Just like that. Oh, Mr. Kitty's not distressed at all. He's like, oh yeah, this is totally normal. Doing water-related activity at work for preschool through kindergarten age kids, and I'll be sure to include all of this next time. Oh, absolutely. This sounds like a perfect thing for level, for that level. I actually would love to hear their logic. Like, hearing kids' logic on this kind of stuff is really, it's really fun to see how they think. It is really, really neat. Oh no. Alright, you 5-year-old, is water wet? The forbidden wisdom. You know what really upsets me? Speaking of things about water. Apparently, did you know that water is not a beverage? Hey, Water Knight, welcome! Perfect timing, Water Knight. We're talking about water. It's okay, I'm ready to sleep through class too. Well, the class is over, but I'm in bed now, so I'm gonna just, you know? Yeah, isn't beverage exactly? That's what's so upsetting to me. I'm always like, oh, Mr. Kitty's having a beverage, but he's not, because he's drinking water, and water is the only thing that you drink that is not a beverage, and that is like deeply upsetting to me. Somehow, I genuinely can't explain it, but it's really yeah, look it up, Maury. Water's not a beverage. A beverage is specifically something that you drink that is not water. I mean, it could be argued to be a very mild carbonic acid, right? Right? It's like how LaCroix is not water. The more you know, right? I'm trying to think of other things like that that are deeply upsetting to me, and I genuinely cannot remember. I think for some reason the water's not a beverage one really sticks with me. We all know annoying trivia I'm bringing into work all week. Good. Go upset your coworkers with this. Accept this forbidden knowledge. Oh man. Southerners called soda Coke drives me nuts, but that's not a fact. That's just. I'm annoyed that astronomers think everything isn't hydrogen and helium is a metal. I don't even. I don't, that's upsetting to me. That's upsetting to me. I'm now mad at astronomers too. We need to hunt down Z, and we need to ask Z how she could let this happen. She is clearly the one who decided this. I have decided that she decided this, and I'm gonna yell at her. What about oxygen, nitrogen? All metals, apparently. Have you ever seen a solid noble gas more? I can sense my high school chem teacher rolling over, like her hand is twitching looking for a baseball bat. Just like I sense a disturbance in the force. Mylan is saying horrible things. Oh no. Oh no. I'm not qualified to talk on any of this at all. Oh no, I'm genuinely getting sleepy. Ever since I drew this bed under me, I'm genuinely getting sleepy. This is a little embarrassing. It's only like 8:30. Why am I so sleepy at 8:30? Oh, I got a decent sleep last night too. This is so sad. I think all this talk about metals and stuff is draining my brain. I am curious though now, like, what would you call a carbonated beverage? What is a sweetened carbonated beverage? So some people call it soda, some people call it pop, some people call it Coke. Just kind of curious. It's soda in Japanese, right? Soda. Right? I think it's just soda in Japanese. I'm not sure about any other languages, though. Speaking of, I want some. Cola? Oh, right. Cola's also an option. Pop is allowed. I don't actually like pop. I pretty much always say Coke. Oh, that's interesting. Cola. Oh, cola. Right, yeah. Cola. I mean, cola. Yeah, exactly. Cola. Or cola is different from cola. It's the I rarely ever refer to them not by their brand names. That's fair. I have some soda that I would really like to drink right after this. Soda ne. Okay, how is Pepsi a Coke? Soda. Soda ne. Oh, how do I always forget. I think soda. Fizzy drink. Oh, I've also heard fizzy drink. I haven't heard fizzy drink in a long time. Which one is N? Is this N or is it? I think this is N and this is so. I think. Can't remember. Can't remember. Why are there so many things? There's like katakana. I hate katakana. Pepsi's basically Coke. Anything fruit-based is Fanta, etc. I see. Where's root beer then? Where's root beer on this spectrum? I'm fascinated. I need to know. I usually just call them happy juice, to be honest. I feel like people might misunderstand that. I feel like when you say something like that, people assume it's some sort of alcoholic beverage or something like that. Anyway, here's my rant. You have no. You have You have so. And then you have re. How can this be allowed to stand? How is this permitted? Oh yeah, we could get into Tsu and she. Or which one's Sue and which one's she? I can't remember. N is so okay. Okay, so I have them right. I don't know. I don't know anyone who drinks root beer. I think that's mainly an American thing. One is lined up horizontally, the other's I know that bit. I know that much at least. So my katakana's right. I'm so good at this. I know katakana so well. Everybody should drink root beer. Root beer's good. This is why I can never move to Japan, because root beer, I love root beer. Root beer's very good. Root beer is love and life, and I want to go to a root beer tasting party. So it's like what? A, O, U, Ka, Ki. In Japan, it's masochist soda. It's good though. It used to be my favorite. It was my favorite soda for a long time. I don't understand. Why are people so mean? People just have no taste, you know? I say as a candy corn enjoyer. I have no rights. I like candy corn. Therefore, I have no rights. No, it's A-I-U-E-O. I don't... You want to fight me? You want to fight me? I will... Meet me in a Denny's parking lot. After I successfully draw candy corn. The superior snack food. It's very important that we successfully draw the candy corn. Look at that. Square! You want to come at me? I'll come at you. I'm gonna defeat you in battle. Candy popcorn. What? Like caramel corn? Or kettle corn? I love kettle corn. I love kettle corn. Kettle corn is good stuff. Can I... Oh no, this is dangerous. I'm sorry, I'm having fun. And then... I am the Demon King, by the way. You must defeat me. Answer these riddles 3. What is the primary source of variance? Or no, how do we... Why do we use variance within treatments to estimate sampling error in ANOVA? This is my first riddle. If you don't answer all the riddles, the world will end. I'm kidding, actually. That's not a riddle. You know what's a riddle? What is the central limit theorem, and why does it make sense? Why does the central limit theorem justify anything? That's not a riddle, but I get the logic they were going for, but I think it's deeply flawed. This is my personal opinion on the central limit theorem. I say this as the demon lord of statistics. The central limit theorem is given way too much credit, and we shouldn't trust like that. Thus spoke the demon lord of statistics. What are my other spicy statistics opinions? If you don't have at least 50 people per condition, there's no point. The p-curve is stupid. The p-curve is a stupid index of replicability. that misunderstands what p-values are and how they work. Spicy statistics takes. We should be using the absolute value to deal with deviance scores when calculating measures of variance. We shouldn't be squaring numbers. That's my spiciest statistic take. We should be using the absolute or the standard deviance instead of the standard. What is it called? What's the name for the? Let me look this up. It's the standard deviation, but with absolute value. There's a name for it. The absolute deviation. We should be using the absolute deviation instead of the standard deviation. This is the platform that I, as Demon King, will rise to victory upon. Please appreciate me. Come with me. We must overturn the laws of statistics. We're no longer using the standard deviation. We're going to use the absolute deviation, okay? Come with me. We will win the battle. I don't know what I'm talking about. I think it's probably time that I go away. It's probably time that I go back into hibernation, actually. I'm talking nonsense at this point. You'd back me up. Who exactly is being fought? We're fighting against everybody who says the standard deviation makes more sense. I've read papers on this now because it pissed me off why we square these numbers to add up deviation scores and get the average distance from the mean instead of just taking the absolute value. And I read this up, and apparently taking the absolute value and then versus squaring all the numbers and then taking the square root actually gives you a slightly different answer. And apparently the reason they agreed on standard deviation at first was because it performed better assuming you had population data. But for the type of data that we actually normally deal with, apparently the absolute deviation performs better. And frankly, it just makes more sense to me that if you want to stop numbers from being negative, just take the absolute value instead of squaring them and taking the square root. I think it makes more sense. So I really think that we need to fight the status quo, and we need to argue for using the absolute deviation instead of the standard deviation. Obviously, I have not read as much on this issue as I should, probably. Which is why I'm only voicing this as Demon Lord Myelin instead of normal Myelin. Demon Lord Myelin, of course, you can tell because I have horns and evil wings, and bat wings are not inherently evil, but I look slightly eviler than usual. There, even better. You can tell that maybe I'm not as trustworthy, and therefore I'm advocating for something without fully doing my research on it. Which is we should switch to the absolute deviation instead of the standard deviation. Does Demon Lord Myelin have like any powers or just has more wings? My power is saying things I will regret in the morning. My power as Demon Lord Myelin is saying things that I will regret not just in the morning. The second I turn off stream, I'm going to start regretting everything I say. That is my special power. Like, normally, I only regret, like, 5% of the things I say. But this is my special power. And all that negative energy gets stored up into power, so I can release a great force, a psychic blast of social anxiety. This is my most powerful attack. This is how we conquer the world. This is how we win. I mean, I could clip when you said I sucked. I was reading chat. You put that. Please don't. Please have mercy on me. Have mercy on me. I'm not a demon lord. I'm just a little baby moth. Please. See, I'm completely innocent. I have never done anything wrong in my life. I'm just small and scared and very tiny, and please don't, please Have mercy on me. Have mercy on me. I don't want any more feet-related things in my life. I really don't. Why does it come to this? Why does it always come to this? Oh yeah, I should probably end the stream. I don't know what I'm doing. I'm not doing anything productive at this point. I don't think I have the power to yap. Yeah, twice is a coincidence, 3 times 2 inches enough for anyone. No more toes, no more feet, no more nothing. Just watch. My next model is not going to have any feet. It's not going to have any feet. And I'm going to blame all of you. I'm going to blame all of you. I'm no more feet for me. Not even on my legs. Feet have been stream rules. No feet allowed in this stream. Leave your feet outside the door. Oh. Surely this will solve the problem. Surely this will not create any more future problems for me. Surely this cannot possibly take off your shoes and your feet. You know, okay, I'll be ghost. You just gotta, like, leave your feet outside the room. And so you're just sitting there with your feet outside of the room where you're watching the stream. Your legs are stretched over the doorway. So technically there are no feet in the stream. This is a foot-free zone. I don't watch the VOD. It's a good thing. I think he's playing Minecraft right now. I think we're safe. Save everyone the trouble of drawing feet. Oh my gosh, yes. You know what? Everybody complains about drawing hands. Drawing feet is worse, and drawing shoes is even worse than that. This is another reason why in my next incarnation I simply will not have any feet. There are many reasons to not have feet. I think that we should all just have wheels. Surely this couldn't possibly go wrong. Especially if you live in a hilly area, it'll be fun. Over-reliance on wheels got me my first major scar. Yeah, I'm drawing something for Nep, and I have gradually encroached to cut out the feet. See? It's horrible. Luckily, it is much easier to keep feet out of a picture than it is to keep hands out of a picture. So, like, most pictures do not actually require that you draw any feet at all, which is lovely. But I'm drawing more VTuber models lately, which means I have to draw more feet lately, and I am suffering. I'm suffering so much. I'm drawing shoes. I think shoes should also be banned. I don't think we need feet. I think we all need to learn how to levitate. Yeah, a glass and well-placed plant pot are covering the hands. Perfect. Genius. This is the strategy. See, when I was younger, I would simply just have all my characters crossing their arms behind their backs. That was simply how I did it. It was genius. How did I do this? I would be like, where's my pen? I was like, here's a guy. There's neck. Here's torso. And then, ta-da! It's perfect. Well, we drawing ghosts now. It's true. Let's draw a ghost. I have an idea for, like, a ghost VTuber model that I want to draw. I think it would be really cool. Somehow this looks like... I can't explain it, but it's giving elephant. I can't. Yeah. It is a great aura pose. It's like, look how cool I am. Look how neat. I'm so strong. I'm so powerful. Oh man, I need to stop. I need to go to bed. Ooh, pick me. Yeah, Maury. Yeah, Maury. I'll make you a ghost VTuber model. I'll do it. You just have to you have to prevent yourself from stopping me from making you a ghost VTuber model, and that is the ultimate test. You only get the model if you fail to stop me. Not for elephant though, just a regular ghost, yeah. I was thinking it would be fun if it's just like a bunch of layers of sheets that like just go like that, and like the top of the torso fades out into nothing, and it's just like relying on a lot of transparency. Like layers and layers, and no part of the model would be fully opaque. All of it would be at least somewhat see-through. Yeah, my idea for model's a ghost, but very specific, and it has legs. This is your... We must make Astral a model. And then... Oh, wait, I'm hiding. There. This. And then, when you come into my stream, your model has to change into this. It's the law. What could possibly go wrong? It's the law. Okay. What? You little guy. You can give the little guy head pats. You know? Gotta give the little guy some head pats. Just like Signalis. I need to look up Signalis. You keep talking about Signalis, and I don't know anything about Signalis, so I should probably look into it. I should probably do that. Oh man. Yeah, I think I need to sleep. I think I need to sleep. I think this is the only thing I can do. I have no idea what Signalis is over then. There are lesbians. This is my understanding. The PS1 graphics make it look like no one has feet. It's the perfect game. It's the perfect game. A world where no one has feet. This is all I need. I feel like I'm overcorrecting. Oh no. I've been yapping for like half an hour. It's definitely time for me to just go lay down. Yep, otherwise it's the perfect place to live. I'm sure there's nothing wrong. Having no feet is the only downside. I fail to see why having no feet would be a problem, okay? Imagine how powerful you'd be. Everyone would want to draw you. When someone has to tell you they don't have a thing for feet, I'm immediately suspicious. I have a thing for the absence of feet. You know, do you ever, like, say something and then, like, the sentence isn't even completely out of your mouth and you're like, oh, I regret this, but I feel like I can't stop now. Like, this sentence has momentum, and it's just gonna come out of my mouth no matter what. I hate this. I hate this. I don't want to draw feet. I need to stop talking about feet. Maury, just please come over here and just knock me unconscious with a sledgehammer. I think that's the only thing that can save this situation right now. It was nice knowing all of you. No one is making you draw feet. You don't know that. In fact, there is somebody who's making me draw feet. Well, they're making me draw shoes, which... all I got is a frying pan, boss. That'll work. Yeah. But no, like, you don't understand. There is currently someone out in the world who is making me draw feet. You need to understand the life of an artist who takes commissions. Well, they're paying me to draw feet. Not just feet. The feet are attached to an entire full body. But I still have to draw the feet as part of the body. They usually are. Most feet are attached. Okay, I'll stop at their place with the frying pan first. Do they pay good? They do pay good. Please don't commission me to draw just feet. I will turn you down. My commissions aren't even open right now. I'm not taking any more commissions. I'm not taking any more commissions. I'm not drawing any... I'm not gonna draw any feet. You couldn't pay me to draw feet right now. You couldn't pay me to draw anything right now, really. How much would it take? More than you can afford, buddy. I need to put that on my will not draw list now. Will not draw. Feet. Do you think I can get away with that? If I only took like waist up commissions, I could probably get away with that. Pretty easy, huh? Won't do. Mecha, not safe for work. Feet. I actually will draw mecha. Like, I barely ever draw mecha, but back when I was in the Overwatch fandom, I actually learned I'm decent at drawing robots. Yeah, you know, I'm broke as hell, but if someone did show up with £1,000,000 in cash, would you? No. No. No hesitation. I would not draw feet for £1,000,000 in cash. Mecha feet. I'd draw mecha feet. I'm willing to draw some mecha feet. Largely because they're basically triangular metal slabs, and that's not a problem. You're stronger than me. I have principles, and those principles are I'm not gonna draw feet. 1,000,000 euros cash is not enough. You can make that 10 million euros, 100 million euros cash, and I would still not draw you feet. What is something that I would give up all of my deeply held values for? The euro, the pound! That's a pound, you're right! The pound is stronger than the euro. I'm sorry, I read that wrong. That is a pound. Symbol. I still would not draw feet. I don't care if it's the strongest currency in the world. What is the strongest currency in the world right now? The Kuwaiti dinar. Oh. It's the only thing we have left after Brexit. I'm so sorry. I'm so sorry. Well, that's interesting. I would not have guessed the Kuwaiti dinar as the strongest currency. Not the USD, that's true. What's the weakest currency in the world? Weakest currency in the world. The Laotian... No, wait. Top 10 weakest currencies in the world 2025. The Lebanese pound. Iranian rial. Vietnamese dong. Laotian kip. Sierra Leonean leone. Monopoly money. I've seen what happens in Monopoly games. I feel like Monopoly money cannot be weak if it is making people go that feral. YouTube. Oh no. Oh no. Yeah, okay. I need to stop. I need to stop and take it. Maybe a piece of paper with "This is very valuable" written on it. Oh, hey, Marlon! Sorry. See, this is how sleepy I am. I didn't even notice that Marlon had appeared. I'm sorry. Welcome to whatever this is. You know, value is subjective, right? That piece of paper might be highly valuable to one person and worth nothing to another person. Monopoly money value is dictated by the deepest, darkest desires of the player. It's true. To be frank, Monopoly money's pretty good in the context of the Monopoly market. This is also true. This is also true. I wonder if anybody's ever, like, done, like, Z-score purchasing power of Monopoly money versus, like, other currencies. I can feel my brain leaking out my ears right now. This stream hit a high point when I answered the question about a line becoming a square over time, and it's just been on a steady decline since then. I heard that somebody got a real-life bank to accept Monopoly money. Nice. I bet you could put it in a safe deposit box. That would be an easy way to accomplish that. At some point, it'll have the material value of cellulose that's printed upon at least. This is also true. I'm also always on the lookout for scrap paper. I have a giant pile of scrap paper in my office. Like I used to share an office with somebody, and that person would always like, she'd try and print out her notes for class, and she would fail. And like she'd just print out giant copies of the slides. So she'd give them to me so I could use them as scrap paper and like doodle on them. By the way, is the dollar really just like paper? No. No, the dollar isn't paper. It's like, I think it's almost like a kind of synthetic fabric, but also not really. What is it made of? It's not like normal paper though, for sure. Oh yeah, no. It literally is composed of fiber. Um, it's composed of 25% linen and 75% cotton. You packed your frying pan on your way. Perfect. Thank you, Maury. I know I can count on you. Yeah, cotton fiber paper. Yeah, I guess if you could call that paper. Yeah, like it doesn't really have the same consistency as like fabric you'd normally expect, but yeah, it's made of linen and cotton. That's why you can put that's why if you accidentally like leave some money, some like American money in your pocket and it goes to the washing machine, it's not the end of the world because it's composed of the same sort of materials that fabric for clothing are. I recall having it almost having a woven quality to it. Yeah, it does. The fibers are a lot thinner than like the fabric that you're used to, used to seeing, but it definitely, can you call that material fabric? I feel like it's made of the same thing of fabric. It's woven. We have plastic money here, which I remember hearing was better because it's more resilient. I've never really encountered plastic money. No, wait, I have some Great British pounds actually lying around somewhere. I'll have to look at them after the stream. I mean, I wonder if you could turn wood pulp into fibers and then weave that. I bet you could. It probably wouldn't be very like sturdy. It would depend on what type of glue you were using to hold it together, probably. I mean, there's all different types of consistencies of paper as well. Like I worked in a craft store for a while and like paper is a wildly variable thing. I wonder if paper is more about the material it's made of or like the structure of it. Like how do you define something as paper? And you might want to put it through the wash because it's gross. That's true. Cash money is deeply gross and full of bacteria and stuff. I always feel kind of gross when touching it. Paper's susceptibility to washing due to the alignment of the polymer fibers or the chemical composition of it. I have no idea. I'm happy to admit that I am not a chemist or anything like that. I have no idea. I think paper yen is similar to USD material. Is there not paper money in other places? There must be, right? Material manufactured in thin sheets from the pulp of wood or other fibrous substances used for writing, drawing, or printing on as wrapping material. Ah, so we have our operational definition of what paper is. Fibrous substance. So I guess you could consider it paper, even if it's not made of like traditional materials that would be used to create paper. Because cotton and linen, I think, would both be considered fibrous substances, so maybe you could consider it paper money. I'd imagine cotton fiber paper made in a similar manner to wood pulp paper would probably risk coming apart, but I don't know, yeah. And I mean, well, it's woven, which is part of it. The fact that it's woven prevents it from coming apart quite as easily as normal paper. My impression of normal paper, like I've made paper before, but, you know, of course, it's not nearly as high quality of paper that people sell. And it's more like a bunch of pulp glued together is my impression than intentionally woven together. So I think normal paper probably comes now you're gonna make me go on like a how it's made tangent. How is paper made? Like commercial paper. Oh, here's something from the Oklahoma State Extension University. Cellulose pulp derived from wood, other Like I know that it's pulp. You get the pulp. You drain the pulp. So you like soak it in water, you drain the pulp, and then you use some sort of glue to stick it all together. I guess not notionally both cotton and wood pulp are cellulose, but their structure is different, isn't it? Yeah. Yeah, their structure is definitely different, and that probably has something to do with it too. I imagine it's a combination of how it's processed and the structure of the underlying materials and a bunch of different things like that. Um, yeah, okay. You create the pulp, you wash and bleach it, you refine it, which I imagine is like making the pulp even finer, so grinding it down to even smaller sizes for the individual units, which is not a step that I took when I made paper in like elementary school. Beating, so you flatten it all up, sizing, cutting it to size, coloring the fibers later to form paper sheet. We have copper coins for 1 pence, 2 pence, gray metal, nickel, I think, for 5 pence, 10 pence, 20 pence, 50 pence, gold and gray for £1 and £2, and plastic notes for £5, £10, £20, £50, but you never see £50. It's a good red. Plastic notes, fascinating. Yeah. It's always screws me up because in the US, of course, we have $1 bills. And therefore, I went to London once and I was so embarrassed because I could not figure out. I was like, where's the £1 bill? And it's like, it's a freaking coin. There is no £1 bill. There's a £1 coin. And I was like, I don't know what's going on. It was so embarrassing because I was like trying to pay for something and then the person behind the counter was just like, give me your money and I will figure it out. And I was like, okay, I'm sorry. Yeah, they dissolve the cellulose first, then convert it back into a form with long fibers. Yeah, that makes sense. That's neat. We should do crafting together. We should do a crafting stream if I can ever figure out that. Yeah, the reverse is true for me. I was always so confused by America not having higher coins. Yeah. We have a silver dollar. Like we do have a dollar coin. It's called a silver dollar, but you never see them. Like they're not really in common circulation. They're mostly I feel like they're kind of like a novelty almost. They're like a collector's item more than actual currency. I think they used to be kind of currency back in the day, but not really. But yeah, like, and then Japan has the 500 yen coin. I'm sorry, I'm just bouncing around all over the place. That's just wild to me. I get very annoyed with small change, with inflation to the point where it's not much point anything smaller than a quarter. I agree. Apparently, we're getting rid of the penny, but I've heard that it will actually cost us more because then nickels also, because then the next smallest unit would be nickels, and nickels also cost more to create than they are worth or something like that. Yeah, yen goes up to $500 coins. $1 bills seem kind of rare. I like just generally, so like, yeah, like the 1 unit bills seem kind of rare culturally. In the US, of course, we have dollar bills all over the place, but like internationally, having that kind of unit as a bill seems unusual. I agree. I do think we should have higher denominations in coins, because like coins are a lot more durable than bills. Easier to carry. I guess they get heavier if you're carrying a lot of them, but I don't know. I don't know. I'm not in charge of money. I'm not in charge of I'm not in charge of any of this. I'm not in charge of It's probably for the best. Do coins have specific shapes for different denominations? Yes. It's mostly the size. So the dime, which is 10 cents, is the smallest coin. Then there is the nickel, which is 5 cents. Then there is the penny, and then there's the quarter. I think it's the nickel than the penny in terms of size. And then there's also some differences in how thick they are. I think there might also be differences in the edges. I think some coins have like ridges on the sides and other coins don't. I'm not 100% sure. Yeah, they're all different shapes and sizes. The size is the main thing that I notice. Like if I'm just not looking at the coin, definitely the size is the most notable thing. And like if I'm trying to tell coins apart, usually I do it by size if like I'm not looking very closely at them. Quarter's the biggest, dime is the smallest, which is weird to me. Why is the quarter the biggest and the dime the smallest? Yeah, right? Like in terms of value, it's penny, nickel, dime, quarter. So why are the smallest and the biggest ones next to each other in terms of value? That's the weird thing. I mean, quarter's the most valuable of common coins. Yeah, exactly. See? Dimes should be bigger than nickels. I agree. I agree. Why are dimes so small? Yeah, there used to be silver dollar. I think I have a silver dollar. I've had a silver dollar at some point in my life. It looks like you can, guys, you can buy a silver dollar from the US Mint. And do you want to know how much it costs? Wait, let me look. I thought I saw something on the preview, a silver dollar for like $6. All coins have ridges except the nickel. Oh, okay, that's good to know. Oh yeah, most of these are just collector's items. How much is a silver dollar? Where can I acquire a silver dollar? Can't find them. Maybe their price has gone up since I last looked, since they're out of print. Silver dollars were 50 cents. They were? Huh. Those penny pressing machines at various parts. I love those machines. I love those penny pressing machines. Those had to have been like in a weird legal area though, right? Because like, isn't destroying money a federal crime? So how is it that they were able to have those penny pressing machines, right? Sacagawea dollar coins for a while, smaller than silver dollars, ironic. Oh, I think it was those that I had, the Sacagawea dollar coins. I think I had a couple of those. Yeah, I do wonder why I was, I want to know now. Why are penny... Okay, so by the way, if you're not like American, I don't know if they have this in other places, but for like when I was a kid, when I was younger, and I've actually still seen them in some places, but I think they're not as common because pennies aren't as common. There were these machines in like museums and theme parks and tourist attractions where you could put a penny in, and the machine would flatten the penny and put a design on it. It presses the metal into a flat sheet with some sort of design on it that's like related to the thing. So like if you went to a natural history museum, it would like put a dinosaur on it or something like that. And it would give like, it would press it really intensely. So it would be like an oval. So like you'd start out with a penny and then you'd get like this flat oval with like, I don't know, a dinosaur on it or something. Now they mention it, I think the reason penny pressing is allowed is because we hate pennies. They cost more to make than they're worth, yeah. Why are penny presses legal? I don't know how much I can... I'm trying to find something that I can look. Here, I don't know. Here, it seems like it's only a problem if it's for deception, and this is just for a souvenir. Oh, interesting. Oh, they started, so apparently the first elongated, so they're technically apparently called elongated coins, and they started at the Chicago World's Fair. Did I already play the kazoo? No, I left the kazoo in my office because my friend who brought the kazoo, so my friend was very, very kind, and my friend got the kazoo for me, which was incredible. But the way that she transported the kazoo from SPSP was she just put it in the bottom of her backpack. With like no packaging or anything. So it was just, I'll have to clean it thoroughly before I play the kazoo. 4 shapes and 2 sizes and 1 pencil. Backpack asbestos. I know, right? Oh man, I don't want to, like, knowing how gross the inside of my backpack is, I do not want to. I need to thoroughly clean that kazoo before I play. I wonder how penny presser fans will feel about the cancellation of the penny. Yeah, I wonder too. I mean, there's still plenty of pennies just lying around. I have a bunch of pennies, I'm sure. Yeah, but why are they legal? That's what I want to know. I'm sorry, Fi, we've gone horribly off the rails. Legality. It is legal in the US. The mutilation... Okay, so I'm reading the Wikipedia page. In the United States, U.S. Code Title 18, Chapter 17, Section 331 prohibits the mutilation, diminution, and falsification of United States coinage, but it does not prohibit the mutilation of coins if the mutilated coins are not used fraudulently with the intention of creating counterfeit coinage or profiting from base material. So yeah, Marlon's pretty much right. It's like, the point would be it's only a problem if you're either trying to reuse the metal to gain money or if you're trying to pass the coin off for something that it's not. Don't worry, Fi, you definitely didn't miss Mylan saying stuff. I did not say any sus stuff. Y'all are the problem here. Y'all are the problem here. I was just complaining about certain things being difficult to draw and not wanting to draw those things. And y'all are the ones who were taking it in weird ways, okay? I am I am the purest member of V theorem. I am pure as driven snow. I have never said or thought a sus thing in my life. Why are you doubting me? Why? I'm telling the truth. I'm sure of it. I'm sure of it. Y'all are just weirdos. Also, feet are banned. That's right. Feet are now banned from the stream. You're not allowed to have feet here. Fine. Luckily, I don't think you have feet, so you're safe. But everybody else is on thin freaking ice, and they don't have any feet to stand on it. It's an important rule. If you have feet attached to your body, they either need to be not attached to your body, or they need to be outside of the room where you are watching the stream. This is the law. Psionic hoverers here only. Don't have feet, but Fibopodia. Exactly, see? See? You're good. You're good, Phi. You're fine. Psionic hoverers here only. Yeah, I already read that, yeah. And Mori's a ghost, so Mori does not have feet either. Astrologopos has feet, though, which is a problem. And I'm not sure about Marlin. It's okay, though. We'll be fine. Wooden Nick... Oh, no. Sorry, I'm gonna wiki walk. We're getting into dangerous territory. Oh, no. Who's talking to me? Oh, okay. I thought I was in trouble. There were messages directed at me in the V theorem chat, and I thought I was in trouble. I thought Phi was gonna come at me for some reason. I thought he was gonna be like scolding me in the Discord, like, Marlin, you need to stop talking about me. Mori, you're not on thin ice. Marlin's on thin ice. No, wait, I don't know what's happening. Getting kicked out for feet stuff. You're Yaguso. Oh my gosh. I do think that we should absolutely have Phi in a suit. I think that that would be good. I want to draw myself in... Did y'all see those tweets about the VTuber Met Gala? I don't know anything about it, but it looks like an excuse to draw myself in a suit, and I love suits. So I think I might draw myself in a suit. I'm very prepared. Oh, man. Oh, boy. I keep feeling like I'm gonna end this straight. We finished the lecture an hour ago. How are we still here? Oh, no! Oh, no. Would you look at the time? So, it is currently a certain time of day. And do you know what that time of day means? Yes, Marlin is correct. I am late. I need to, yeah. Oh, wait. The beast requires sustenance. I must feed the creature. I will be... I'm glad that we can all agree that this is one of the most important things. Nyalin. Yes, okay, anyway, I must feed the creature. I think this is actually probably a good place to end the stream. Because with the way that the stream is going, it's just going... We're tobogganing downhill at a rapid pace. So I think I'm gonna end the stream now. And I'm gonna feed the kitty, descending into incoherence. I think we've been in incoherence for a while now, and we have just been... For a while there, we actually broke out the other side of incoherence back into actually somewhat comprehensible rambling, but we're rapidly descending back into incoherence, tobogganing down the hill of my Snow White purity. It's true. It's true. I'm the purest, most innocent member of V theorem. I've never done anything wrong in my entire life. I can't keep the laughter out of my voice. This is bad. I'm gonna go. I'm gonna go before I further incriminate myself and by complete accident. I swear. This is why everyone needs to remove their feet. Preserve the stuff. Exactly. Go feed. Yes, okay, I'm gonna go feed the animal. Thank you all so much for coming. It was really nice having you here. It has been lovely. I'll see you in the next stream, whatever, or video, whatever that will be. I don't know what it's gonna be yet, but we're gonna have fun. Thank you all again, and have a great day. Now that the stream is ending, you can put your feet back on. See you next time. Bye.